In this video, we're going to talk through the solutions to the final exam review number 3 for semester 2 of Algebra 1. Alright, so family functions is the first portion. It says determine the function family and provide the prompted information. So when I look at the table, I'm looking at the pattern in the table. We're adding 1 each time to x, and then I'm looking at the y values, and I'm like, okay, well first I subtract 10, and then 5, and then 2.5. So I'm not subtracting the same thing each time, so I know it's not linear. I don't see any symmetry in the table, so my thought is it's probably not quadratic or absolute value. So then my next thought is, well, if it were exponential, I'd be multiplying by the same thing each time. Now I know that going from 20 to 10, I'm dividing by 2. From 10 to 5, I'm dividing by 2. But I need to know, what am I multiplying by? Well, I know if I divide by 2, that's the same thing as multiplying by 1/2. Excuse me. So if I multiply by the same thing each time as x increases at a constant rate, it is an exponential function. The equation for an exponential function is y equals a times b to the x, where a is the y-intercept. So again, I got to work backwards to see where x is 0. So if I'm multiplying by 1/2 to go this direction, I divide by 1/2 or multiply by 2 to go the opposite direction. So that would be 40. So I have y equals 40. And then because the common ratio, the b value, the common ratio is 1/2, I need parentheses around that 1/2. So again, my y-intercept is the a value, and the common ratio is the b value. And if you struggle with figuring out what the common ratio is, you can always take any y value and divide it by the previous one, and it'll give you the common ratio. So 5 divided by 10, 2.5 divided by 5, and so on. You know it's 0.5. If you want to convert that to a fraction, you can go to math, number 1, and it'll convert it to a fraction for you as well. Alright, so now looking at the y-intercept. Our y-intercept is always when x equals 0, and our x-intercept is when y equals 0. Well, the y-intercept I found for the equation, that was 0, 40. The x-intercept, if I look at this and I keep halving all of this, no matter how many times I take the half of that number, it's never going to actually reach 0. So we find that there is an asymptote at y equals 0. So we're never going to get y equals 0, which means you are not going to have any x-intercepts. Moving on to number 2, I'm looking at this graph, and I see it's a U-shaped graph, or we call that graph a parabola. So this graph really goes on forever in both directions. I'm going to name that right here. It's a parabola. When it's a parabola, we know that this is a quadratic function. So let's jump to the domain and range now. The domain are all the x values, meaning going left and right. And as we go to the left, because this graph goes on forever, and it goes on forever to the right, the domain is all real numbers. The range are the y values, and y goes up and down. So I see that this graph has a maximum. The maximum value is 3, and then anything below 3. So we have y is less than or equal to 3. Well, we almost just answered this next question. Is there a maximum or a minimum? Well, because there's a highest point, there's a maximum, and that maximum value will be the y-coordinate of the vertex, because the maximum occurs at the vertex. So the vertex is 1, 3, which means the maximum is 3. The equation, we can write the equation in a couple different forms. We have vertex form, intercept form, and standard form. When I look at an equation or a graph, in order to write the equation in vertex form, I need the vertex and the a value. I got the vertex. We can find the a value by making a table. To write it in intercept form, I need to find the intercepts. And when you look at this, the x-intercepts aren't exactly an integer, so I'm not going to do intercept form. I'm going to stick with vertex form. So vertex form here, y equals a times x minus h squared plus k. Here are my h and k, but I need the a value, so I'm going to make a table of x and y to find the a value. Here's the point 0, 2, so that means that this must be 2, 2. So I can go 0, 2, 1, 3, 2, 2. And as x increases by 1 each time, y, we add 1 and then subtract 1, or it has a common second difference of -2. To find the a value, I know that I take my second difference and I divide that by 2. So a will be equal to -1. So my equation, y equals negative x minus 1 squared plus 3. Remember, it's opposite the sign in the parentheses of h because it's minus h. So if h is positive 1, we're going to see a minus 1. The equation for the axis of symmetry, well, this is your axis of symmetry. That's the equation x equals 1. Make sure we have the x equals. And then listing the transformations of this function from the parent function, I can first look at the vertex. I went to the right 1 and up 3. So I'm going to say translate right 1 and up 3. And I'm also opening down, or my a value is negative 1, so that is a reflection in the x-axis. I have to consider is there a vertical stretch or shrink, and when I look at this, because a is negative 1, the negative reflects it, but the 1 is going to make it the same width as the parent function, so I'm not vertically stretched or shrunk. So that is it for number 2. Moving on to number 3, we're now in absolute value. So looking at this, I know it's an absolute value equation because it has absolute value bars. To solve an absolute value equation, I isolate what I'm taking the absolute value of. To do that, that's a 6 times the absolute value bar. So I'm going to divide both sides by 6. I'm going to be left with the absolute value of 2x plus 3 is equal to 3. Once I isolate the absolute value, I can ignore what's inside and just think through this. If I take the absolute value number and it equals 3, what I'm taking the absolute value of is either 3 or negative 3, because the absolute value of 3 is 3, and the absolute value of negative 3 is also 3. So when I think about that, I realize that what's inside is either equal to 3 or it's equal to negative 3. So as I solve this equation, I subtract 3 from both sides, I get 2x equals 0. Divide both sides by 2, I get x equals 0. There's one solution. Now, if we forgot this other piece, we might be tempted to say it's part A, but we can't forget the second piece. Now if I subtract 3 from both sides, I get 2x equals negative 6. Divide by 2, I get x equals negative 3. So the correct answer is B. So don't be fooled by this multiple choice question. Scooching over to number 4, quadratics. So let's convert the function into standard form. Well, looking at it right now, I know it's an intercept form. I recall that standard form is y equals ax squared plus bx plus c, meaning I'm not going to have any parentheses anymore. So to convert it to standard form, I need to multiply these 3 factors together. And I can do that using distributive property or the area model. Last time, we distributed the negative 2 to the first set of parentheses first. I'm going to do this a different way this time. I'm going to first multiply the 2 binomials and then distribute the negative 2 at the end. So if I want to multiply those two, I could use the distributive property or FOIL, or I could use the area model. If I use the distributive property, x minus 3 times x plus 7 would equal x squared plus 7x minus 3x minus 21. Or x squared plus 4x minus 21. Or, if I do the area model, I would do x minus 3, x minus 7. I still get the same terms, but they're just arranged inside of a box, and I can combine like terms and still get this as my simplified answer. So I have y equals, I'll have a negative 2 times x squared plus 4x minus 21. And now I can distribute that at the very end and get negative 2x squared minus 8x plus 42 as my final answer. Now if you want to do it like we did in the previous video and distribute the negative 2 first to the first set of parentheses, you'll still get the same answer. You'll just distribute first and then use FOIL or the distributive property or the area model. Moving on to number 5, we're still in quadratics. So it says find the product. Well, if I'm finding the product means multiplication. But I don't see this written as multiplication, so really I need to recognize that when you square a binomial, you're really just multiplying it by itself. So if I multiply this by itself, I'll use the area model this time. 2x times 2x is 4x squared. 2x times a negative 6 is a negative 12x. Negative 6 times 2x is a negative 12x. Negative 6 times negative 6 is a positive 36. So I have to add all my like terms. We got the 4x squared. We got our two x terms, or linear terms, 24x. And then we have plus 36. So we got to be real careful because these are all very similar. I have a negative 24, so that's a positive 24. That doesn't have 24 at all. And then positive 36, yep, that's still the right one. So we're good to go. Looking over here in number 6, 6, we're still solving a quadratic equation. Because it has an x squared and an x, I'm realizing this is standard form. When it's in standard form, I first try and solve by factoring. So I need two things that multiply to be 2 and add to be -5. That's my a times c, and that's my b. So as I'm thinking through this, the only things that multiply to be 2 are 2 times 1. And if we multiply to be positive but add to be negative, I know those both have to be negative. But when I add those don't equal -5. They equal -3. There's no other possibility, so this one I cannot solve by factoring. Instead, I'm going to have to solve by quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And as I continue solving, plus or minus the square root of, I can do this either in my head or I can put it in a calculator. -5 squared will be a positive 25. A negative times a positive will be a negative. So I'm going to be subtracting 4 times 2 times 1, or subtracting 8. So 25 minus 8 would be 17. Or, in my calculator, I can put -5 in parentheses squared. Got to have those parentheses, otherwise you're only squaring the 5 and not the negative. And I get 17 that way too. So either way is fine. So plus or minus square root of 17, all divided by 4. Now if I can simplify the square root of 17, I need to, but 17 is a prime number, so I cannot simplify that any further. This is the simplified radical form. If I were asked for the decimal approximation, I could punch that in a calculator and get a decimal approximation. But as far as the final exam goes, if it doesn't tell you to do the decimal, you're good to leave your answer like this. Moving on to number 7. The amount of fence needed to enclose a rectangular yard can be modeled by that, where x is the width of the yard and y is the total area. What is the possible maximum total area of the fence? Okay, so let's draw a picture. We got this rectangle. We know that x is the width, so we'll make that x, and y is the area. So y equals area. And it says, what is the possible maximum total area? So maximum total area means I want to maximize y. Well, to get the maximum, I know that maximum happens at the vertex. So I take y equals -x squared plus 250x, and I need to find the vertex of that. There's a few different ways we can do this. One way is to look at this and say, well, this is standard form, x squared and an x. So to get the vertex in standard form, I do x equals -b over 2a for my axis of symmetry, or x equals -250 over 2 times -1, or x equals a positive, what would that be, 125. Now that's x. That means that the width would be x. So that's the width, but I don't want to know what width maximizes the area. I want to know what is the maximum area. So if the width is 125 and the area is given by this, I can substitute in to find what the area would be. Scooch that over there to make sure we can see the work. So here, now that I maximize the area, or substitute that in, if I put this in my graphing calculator, -125 squared plus 250 times 125, I get 1,506.25. Now that's the area. And it says the area is given in square feet. So it's this many square feet. So looking back over here, B is the correct answer. That one was tricky, but in my head I know as soon as I see that I want a maximum, I know that happens at the vertex, and I got to think through that. Alright, flipping to the back, let's take a look at this now. We're into Unit 8, polynomials and radicals. I want to simplify this. To simplify, I need to see what operation is going on. And I see a minus sign, which really means that that's like a -1 that I can distribute. So I have 7x to the 4th plus 9x minus 6 minus 9x plus 7x to the 4th. And now I can combine like terms. I'm going to do my highest exponent first so that I write my answer in standard form. That's 14x to the fourth. Then I'll take my linear terms. Well, positive 9x and negative 9x add to be 0, so I'm going to cross those out since they add to be 0. And then I'm left with minus 6. So this expression simplifies to 14x to the fourth minus 6. Switching over to number 9, I'm simplifying, and when I simplify square roots, I need to look at what operation. This is multiplying. There's a couple different ways I could do this. I could simplify first and then multiply, or I could multiply and then simplify. So I'm going to do this two different ways. If I multiply first, I can multiply what is underneath the square root, or multiply the two radicands. And now I can simplify this either using the perfect square method or factor tree. So that would be 6 times 10, 3 times 2, 5 times 2. That means that's the square root of 2 times 2 times 3 times 5. Or the square root of 2 squared times 3 times 5. Or 2 root 15. So there's my answer. Or I could have done the perfect square method and said, well, what's the largest perfect square that 60 is divisible by? Meaning 1, 4, 9, 16, 25, 36, and so on. I recognize that the largest perfect square that 60 is divisible by is 4. So I'm going to break that into 4 times 15, because 4 times 15 is 60. Square root of 4 is 2. Square root of 15 is irrational. We leave it as square root of 15. Now, this was all if I multiply first and then simplify. The other option is to simplify and then multiply. So if I simplify square root of 20 using the perfect square method, that I'll break that apart into the largest perfect square that 20 is divisible by, which is 4. So that's 2 root 5. And I still have this times square root of 3. Now square root of 3 is a prime number. 3 is a prime number. Square root of 3 is irrational and cannot be simplified. So I'm still multiplying it times the square root of 3. Well, square root of 5 times square root of 3 is square root of 15. Now, if I could simplify square root of 15, if there's a perfect square hidden in there, then I would have to do that. But there's not, so I could be done. Either way, you get the same answer. Looking at number 10, we want to solve this equation. This is a radical equation, or a square root equation, because I see a square root here. I need to remember when I'm solving a square root equation, I need to undo the square rooting, and to do that, I'm going to square both sides. So I get x squared equals, on the right-hand side, I'm going to be left with 30 minus x, because the inverse of square rooting is squaring. Now I see I have an x squared and an x, which tells me this is a quadratic equation, and a quadratic equation in standard form. So I need to write this in standard form, get it equal to 0. To do that, I'm going to add x to both sides and subtract 30, and realizing that there's no like terms to combine. So on the right-hand side, I get 0. On the left-hand side, I'll get x squared plus x minus 30. And I want to write it in standard form because it'll be a lot easier for me to solve from here. If it's in standard form, I'm going to try factoring first. So negative 30 and 1. To multiply to be negative 30, add to be 1. I know to multiply to be a negative, I need a positive and a negative. And I have a lot of options, but I know that a positive 6 and a negative 5 will multiply to be negative 30 and add to be 1. Because my a is 1, I can jump right to my factors and now use zero product property and solve. If x plus 6 equals 0 and x minus 5 equals 0, that must mean that x would equal a negative 6 if I subtract 6 from both sides, and x equals a positive 5 if I add 5 to both sides. Now, I shouldn't have really boxed that in. I got to see if both of these will work. It's part of the answer, so I might be inclined to think, yeah, they'll both work, but I got to check in the original. So the first one I'm saying, does negative 6 equal the square root of 30 minus negative 6? Well, I can put it in my calculator or do it in my head. It doesn't matter. So the square root of 30 minus negative 6 equals a positive 6. Well, negative 6 does not equal a positive 6. This is an extraneous solution. Let's check with 5. Does 5 equal the square root of 30 minus 5? Well, 30 minus 5 is 25. Square root of 25 is 5. Or I can put in my calculator, square root of 30 minus 5, and I get 5. So this one works. So our only solution is x equals 5. So part C. So we got to be careful of that. We got to remember, anytime we have a square root equation, once you get your answers, you might have extraneous solutions. And remember, that happens because this is going to be a parabola tipped on the side, So we only sometimes have one solution because of the parabola tipped on the side. The bottom half is what gives us the extraneous solutions. Scooching over here, number 11 says simplify. When we're simplifying radicals and we're adding, we have to have the same radicand. These are not the same radicands, but I might be able to simplify this and then add. I'm going to simplify this using the perfect square method. So the square root of 99, I know that 99 is divisible by 9, and 9 is a perfect square. So the square root of 9 times the square root of 11. Square root of 9 is 3, so that's 3 times the square root of 11. Now I'm adding to that 3 times the square root of 44. Now 44 is divisible by 4, which is a perfect square. So that's 3 times the square root of 4 is 2, square root of 11 I still have is 11. So this is 3 times the square root of 11 plus 3 times 2 is 6. So now when I add these, they have the same radicand. I can add the numbers in front and get 9 times the square root of 11 as my final answer. Scooching over here, I'm now solving the equation. Remember, this is a square root equation. We always have to check for extraneous solutions. To undo the square rooting, I square both sides, and I get x minus 5 equals 64. Now I add 5 to both sides, and I get x equals 69. So before I box in my answer, I want to check it. Does the square root of 69 minus 5 equal 8? That's the question. So if I want to do it real fast, and I don't like to do mental math, I can do the square root of 69 minus 5, press enter, yep, it equals 8, I'm good to go. Or realize that's the square root of 64, 8 equals 8, you're good. So x equals 69 is a solution. Over here, I need to isolate what's being squared first. So my first step is to add 15. I get 4 times the square root of x plus 7 equals 36. I divide both sides by 4. I get square root of x plus 7 equals 9. And now to undo the square rooting, I square both sides. X plus 7 equals 81. I subtract 7 from both sides. I get x equals 81 minus 7 would be, what, 74? Again, before I box it in, I want to check my answer. So this time I'm just going to punch in my calculator. Go right back to the beginning. 4 times the square root of 74 plus 7. I got to get outside of the square root and subtract 15. I want that to equal 21 if it's going to be a solution. And it does, so I know that that's a solution. So I box it in. Then finally over here, our last equation that we're going to solve. I want to isolate the square root, so I subtract 16 from both sides. I get 3 square root of x equals negative 6. Divide both sides by 3, and now I've isolated the square root. I square both sides, and I get x equals a positive 4. Before I box it in, I substitute it in. 3 times the square root of 4 plus 16, does that equal 10? Well, the square root of 4 is 2. And just using order of operations, I continue to simplify. And I get 22 equals 10. Well, 22 is not equal to 10. This is extraneous, which means there is no solution. Moving on to number 13. Directions say simplify the following radical expressions. So these are all square root expressions. The first one, when we say simplify, you're not adding, subtracting, or multiplying. So all we have to do is simplify the radical. I'm going to simplify each of these separately. So the square root of 50, if I do a factor tree, 5 times 10, 5 is a prime number, this is 5 times 2. So this is the square root of, that'll be 5 squared times 2, or in other words, 5 times the square root of 2. So that's simplifying the square root of 50. If I simplify x to the third, that's 3 x's multiplied together, or the square root of x squared times x. Well, the square root of x squared is x. Square root of x is going to stay underneath that square root. There you go. So I got 2 parts so far. Then square root of y to the 8th, got a lot of y's. 1, 2, 3, 4, 5, 6, 7, 8. If I pair them up, I'm going to have 4 pairs. The square root of y squared is y, and if I keep doing this, I'll end up getting 4 y's multiplied together, or y to the 4th. So to combine these, I'm just multiplying all of them together. So I have a 5, an x, and a y to the 4th that will be all multiplied together outside of the square root. And then underneath the square root, I still have a 2 and an x. So here's my final answer. Looking over here, there's a couple different ways I can do this. I could multiply these two numbers together first and then simplify, or I could simplify and then multiply. I'm going to choose to simplify first and then multiply, and there's a specific reason this time. The square root of 16 is a whole number. It's just 4. So I'm going to do this as 5 times the square root of 20 times 4, which is really just 20 times the square root of 20. Divide this up here. Now I can simplify square root of 20. So square root of 20, again, we can use the factor tree or the perfect square method. Because I know right away that 20 is divisible by 4 and 4 is a perfect square, I'm going to break that apart into the square root of 4 times square root of 5. So we still carry down the 20. The square root of 4 is 2. Square root of 5 is irrational. That stays there. So now this is 40 times the square root of 5. And this is our simplified answer. For part C, we're adding and subtracting. We know we can only add and subtract radicals that have the same radicand. Now these two already have the same radicand, so we could add those. That would be 8 root 3, because there's a little imaginary 1 there. But we're minusing the square root of 27. We can't stop yet, though. We have to see, can we simplify square root of 27? And if we do that, the square root of 27, if I do a factor tree, I have 3 3's multiplied together. So that's the square root of 3 times 3 times 3, or the square root of 3 squared times 3, or 3 times the square root of 3, because the square root of 3 squared is 3. So now we have 8 times the square root of 3 minus 3 times the square root of 3, which, because they have the same radicand, we can keep that radical and add the numbers in front, or in this case subtract them, and we get 5. So 5 times the square root of 3 is our final answer. And then moving down, this is just some Unit 8A review. It says perform the indicated operation, and we want to write our answer in standard form and classify the polynomial. Okay, so looking here, we're multiplying. In order to multiply a binomial times a trinomial, I like to make box, because I just think it's so much easier to organize. You don't have to do this, though. You could use the distributive property and write all of your terms in one long row if you want. So x times 3x squared would be 3x to the third. X times 7x is plus 7x squared. X times negative 2 is a minus 2x. Negative 5 times 3x squared is a negative 15x squared. Negative 5 times 7 is a negative 35x. And negative 5 times a negative 2 is a positive 10. And from here I combine like terms. So I have 3x to the third. When I add these, I get minus 8x squared. When I add these, I get minus 37x, and then plus 10. So here's my answer in standard form. To classify it, I need to look at the degree and the number of terms. The degree is 3, so this is a cubic. There are 4 terms, so we just say polynomial. Moving on to part B, we are subtracting, which means I'm really distributing a negative 1. So 5x squared minus 80x to the third plus 10 minus 5x to the third plus x squared minus 10. So I've distributed the negative 1, and now I just combine like terms. I look at my x to the third terms. I have a negative 80x to the third and a negative 5x to the third. Those add to be negative 85x to the third. Now I have my x squared terms. 5x squared plus x squared is a plus 6x squared. And then finally my constant terms, 10 minus 10, or a positive 10 and negative 10, add to be 0, so I'm done here. To classify this, I look at the degree and the number of terms. The degree is 3, so again, this is a cubic. There's only 2 terms this time, so it is a cubic binomial. Moving on to number 15, we're asked to factor the expression completely. I know my first step in factoring is to factor out the GCF. The GCF of these 3 terms, well, I look at 16, 80, and 100. I know they're all even, so they're divisible by 2. Let's see if there's a bigger number they're all divisible by. I know that 16 is divisible by 4, 80 is divisible by 4, and 100 is divisible by 4. So maybe it's 4. Well, there might be a bigger number. I know 16 is also divisible by 8. I know 80 is divisible by 8. Let's check 100. 100 is not divisible by 8, so that's not going to work. So our GCF will include a 4. And then I look at the rest of these terms. I have an x to the third, x squared, and an x. Well, they all have an x I can factor out. So the GCF will be 4x, and I'm left with 4x times 4x squared gives me the 16x to the third. 4x times a negative 20x gives me negative 80x squared. And 4x times a positive 25 gives me 100x at the very end. I have to see if I can factor further. Because this is quadratic, meaning I have an x squared, I might be able to factor further using factor by grouping. So two things that multiply to be a times c or multiply to be 100 and add to be negative 20. Well, I know those numbers are negative 10 and negative 10. Because a is 1, I'm going to do factor by grouping, and I can either do the box or in a row. I'm going to choose the box just because it's helpful to organize sometimes. So my first term and my last term, and then my two terms for my product sum. The GCF of these two would be a 2x. 2x times 2x is 4x squared. 2x times a negative 5 is negative 10x. The GCF here, because the leading coefficient is negative, I'm going to factor out a negative 5. And negative 5 times 2x is negative 10x. Negative 5 times negative 5 is positive 25, so I'm good. So I have my GCF, and then my other two factors are written out here in parentheses. Because they're the same thing, I can write my final answer as the quantity squared. And here we go. All right, almost done. Last problem, number 16. Find the zeros. I remember that zeros are just like x-intercepts, and I find x-intercepts by letting y equal 0. So I have 0 equals 7x to the fourth minus 112x squared. First step is factoring. So I got to factor out the GCF. The GCF here, well, let's see, is 112 divisible by 7? I don't know that in my head. It is. It's 16. So if I factor out a 7, I know both 7 and 112 are divisible by 7. This has an x to the fourth, and this one has x squared. So the GCF would include an x squared. 7x squared times x squared would give me 7x to the fourth. 7x squared times a negative 16 would give me negative 112x squared. Now, at this point, it's quadratic, so I could see if I could keep factoring, and sometimes you'll be able to. Sometimes you won't, but either way, because this is an x squared and there's not another x, I could solve excuse me, using the square root method or inverse operations. We're going to continue trying factoring, though. So two things that multiply to be negative 16, and this time b is 0, so add to be 0. That would be 4 and negative 4. Because a is 1, I can jump right to my factors. I have my GCF, but now this will factor to x plus 4 times x minus 4. Now that they're both linear terms, I can't factor it any further, and I can solve using zero product property. If I set 7x squared equal to 0, I'll get x equals 0. If I set x plus 4 equal to 0, I'll get x equals negative 4. And if I set x minus 4 equal to 0, I'll get x equals a positive 4. So here are my three solutions. Recognize I could have set both of these factors equal to 0, and when I did x squared minus 16 equals 0, I would add 16 to both sides, then take the square root, and all I have to remember is that I need a plus or minus here. So this is another option. Just remember you'd have to have the plus or minus when you solve by taking the square root. That gives us both of those answers. All right, and we are all done with the review number 3.